All right, here we go on finding the derivative using the fundamental theorem of calculus. So some of the problems are fairly straightforward in that our upper limit of integration is simply x. So we plug in x for t, and the derivative, big F prime of x, is equal to the square root of 2 minus the sine of x. We love it when it's that easy. Number 2 is also that easy. Big F prime of x equals, plug x in for s, we have the tangent of x squared. Then we start to have to deal with a chain rule situation. Whenever your upper limit is not just plain x, you have to deal with the chain rule. So g prime equals, I plug in x cubed for each t value. So in my denominator I have x cubed cubed, and I raise an exponent to the exponent, so I multiply. So it'll be x to the 9th there. Then I have to multiply by the derivative of x cubed, which is 3x squared. So this guy comes out to be 3x to the 5th all over the square root of 1 plus x to the 9th. Number 4, once again I have a chain rule situation. So I need g prime of x equals, and it's the cube root of 1 minus cosine of x squared. So cosine squared x times the derivative of cosine, which is negative sine x. And I don't know of a good way to write that any better other than, I guess, now I'm going to go there. Let's see. It's still a cube root here, but 1 minus cosine squared is sine squared times negative sine. And I don't know if your answer key did this, but this is really sine of x to the 2/3 times negative sine x. So that gives me a negative sine x raised to the 5/3. And like I said, I don't know if your answer key went to that level of detail, but you could. So now, big F prime, number 5, we have upper and lower limits of integration that are variables. So we end up with e to the x over x for the upper limit, no chain rule because it's just an x, yay, minus e to the rad x over rad x, and now I do need a chain rule here, so the square root of x differentiates to 1 over 2 rad x, and I can clean that up. So I have e to the x over x minus e to the square root of x over 2x, and look at this, if I get a common denominator of 2x, I have 2e to the x minus e to the square root of x. That is our big F prime. And then I have a little bit of space down at the bottom to do number 6 to get y prime equals sine of t to the 4th. So it's really 3x plus 1 to the 4th. And that is the whole 4th expression is within your sign, times the derivative of 3x plus 1, which is 3, minus sine of, instead of t to the 4th, I need 2x to the 4th, times the derivative of 2x, which is 2.